I'm welcoming everyone to this video. I am Mr. Ish. I hope everyone's doing well. Let's evaluate this integral. We're looking here from 0 up to infinity sine x over e to the x. This right here makes for an annoying integral, and I'll talk about momentarily why. It's fun, but it's annoying. You would be better off just rewriting this as e to the minus x sine x, and then you're looking at that 0 up to infinity. That infinity compounds the problems a little bit because we're looking at something which is improper. What are some of your limits which are involved? When you're looking here with regards to 0 and infinity, if you said limit as x approaches 0, I have e to the minus x, it's defined because you know it's equal to 1. If you said limit here as x is approaching infinity, I have e to the minus x, again it's defined as equal to 0. You're looking here at a function which would look something like this, 0, 1, y-intercept is looking like that. As x approaches 0, your approach is y-intercept of 1. As x approaches infinity, you approach your horizontal, as I'm told right here, which would be y equals 0. Hence, these outcomes that you see. But that's good. Now let's look at that sine x. With regards to the sine x and or its antiderivative, if you looked at it in a positive manner, if you did limit as x approaches, let's say 0, you have sine x, you know that's equal to 0. But if you were to doing cosine x, you know that's equal to 1. That's good. Now let's look over here. If limit as x approaches infinity, we looked at sine x, or we were looking at cosine x. What do we put over here? Because it could pop up. You know, with regards to the range, let's say the range of the sine and the cosine is always between minus and 1. It'll always be a value somewhere between here. At infinity, we don't know where it is. Is it minus 1? Is it 1? Is it any bunch of numbers in between? There's ambiguity, but you can throw out that ambiguity. Generally, you would say a limit does not exist, but if you throw out that ambiguity, you could say here our answer is somewhere between minus 1 and 1. We don't know what it is, but it is a value over there, and we will pretend there's no ambiguity and we just roll with this limit and we'll see what happens. This is one of those areas where it becomes annoying because you have a situation such as this, but you're going to assume the ambiguity is not too bad and you can still work with it, and perhaps a limit exists. Let's solve this definite integral and see what happens. Our integral is this rewritten in this different way using laws of exponents. We will throw out the formal procedures of solving improper integrals. Let's just get right into it. We won't get lost in the formalities. 0 to infinity e to the minus x sine x. I'm thinking over here integrating by parts. We may have to do 1 or 2 rounds. If let's say u is equal to e to the minus x, then you know derivative of this is minus e to the minus x dx. V is equal to what? The integral of what remains, sine x. When you do the integral of sine x dx, you have minus cosine x. These are the items you'll bring into play. What will you bring them into play? Into uv minus integral v du. Plug in the items uv. I have a u and I have a v. I will look here at minus e to the minus x cosine x because there's a minus coming from right here. Then I have this minus, and then I have this integral v du. You have a minus cosine x, du is minus e to the minus x dx. Let's do some simplification. I have 2 minus signs. I can eliminate them because they cancel out, and I'm just looking at this. This is what I have. And now I can do another round because I have something which looks like that. I should do another round of integrating by parts. My substitutions will remain the same except here. When I'm looking at this part, I can change this into a cosine x because now I'm looking at a second round where the function has changed, and then over here I'll have a sine x. When we do the second round, we do everything over here, we bring it in. I have a minus e to the minus x cosine x. Then I have this minus, then I'll do uv minus integral v du. uv, what's u and v? It'll be sine x and e to the minus x. I'll have here e to the minus x sine x. Then I'll have minus integral v du, which will be a what? It'll be a sine x, and du will be a minus e to the minus x dx, and we'll close it out. You have to open up these parentheses. When you open these parentheses, this minus will impact everything. It will convert this into a minus, as you see right over here. This term will be a minus term. I have this minus, and this minus will become a positive, but with that it will remain a negative. When we remove this, we're looking here at a positive, but we had a parentheses over here. That parentheses would have converted this into a negative, and we will remove that, and we'll remove the effect of the parentheses, and we'll make it into a negative. And there's nothing wrong I've done over here. I've just skipped a few steps over here with the parentheses, but I've opened everything properly by applying this negative as it should have been applied. When you're looking over here, all of this is equal to your original integral, which is equal to e to the minus x sine x dx. You have this and you have this. They look alike. If you were to push this entire item onto the other side, algebraic manipulation is all what we're doing over here. If you were to push this minus will add over here, become plus. You're essentially doing, this is what you're doing. You have something which is here, all of this x. I have a minus a is equal to a. You push this over here, you have x is here equal to 2a. This right here doubles, this right here will go on the other side, it will double. Nothing wrong with what I'm doing. It's algebra. I have all of this over here, which I will write as minus e to the minus x cosine x minus e to the minus x sine x is equal to 2. And then I have your original integral sine x e to the minus x dx, because this went on the other side, it doubled. Minus and going on the other side, it added, it doubled it. This is what I have. Look over here and isolate minus e to the minus x. I'm looking here at cosine x plus sine x. Nothing but algebra over here in play is equal to this. You'll solve for this by pushing the 2 on the other side, it will divide. Now you're seeing all of this come about. I'll make some space here on the top and then we'll finish this. Don't worry, I haven't forgotten about these limits. We'll bring those into play momentarily. Up till now I've avoided them, but now I'll bring them into play. When all of this is coming into play, I have 2 integral sine x e to the minus x is equal to this. Then the integral sine x e to the minus x is equal to this, coming onto the other side and dividing. I'll have integral sine x e to the minus x. My original integral should be equal to this divided by 2 minus e to the minus x over 2. Then I have cosine x plus sine x. And I have all of this being impacted by my limits infinity and 0. Everything has come into play appropriately. Let's remove this. Now how will we go about doing this? We'll put the upper limit, we'll put the lower limit. Now look, when we put the upper limit over here, this is where we can get away with it. I have minus e to the minus infinity over 2, then I have cosine infinity plus sine infinity. This is the upper limit coming in, minus the lower limit. I'll have minus e to the minus 0, which is just a 0 over 2. I'll have cosine 0 plus sine 0. You just have to compute this and then we'll be good. Fortunately, you don't have to worry about this because e to the power of minus infinity is equal to 0. You have a 0 times all of this will 0 out. All of this zeroes out by effect of this. E to the minus infinity is 1 over e to the infinity, which is 0. 0 cancels it all out. I'm looking over here at a 0 minus. Sine of 0 is a 0, cosine of 0 is a 1. E to the 0 is always equal to 1. I have a minus 1 over 2 times 1. This is 1 coming from a cosine 0. I have a minus 1 over 2 coming from here. You open it up. What do you have? A positive 1 over 2. And that right there is your end result of this integral, and it should be good. And it brings us to an end. Thank you for watching.